Voila! And that was all I know in French. No, je parle français un peu. Yeah, I learned for 6 years in school and I don't remember anything. But when I'm in French-speaking environment, some things come back to me. Like random words, like poisson.
Poisson?
Yep, poisson.
Poisson
Like fish.
Okay. Because it can be poison or fish.
Oh, that, which, you know what? My son would claim it's the same thing.
Poisson and poison.
Poisson and poisson.
Yes.
And fish is poisson. Ah, so close! All right. Okay. Thank you very much for being for coming. I'm very excited to see that many people after COVID. You know, it's a very large group of people for a meetup. So thank you very much for coming. We are going to talk today about developer productivity. And we have a very fancy name for our presentation. It's called A Dual Perspective on Best Practices in Testing in Dual Perspective in Developer Productivity. What do you think about when you think about dual perspective in developer productivity? Well, good coffee is one perspective on developer productivity, and the noise cancellation headphones, it's another perspective on developer productivity. The trick is we're going to talk about neither, because we're going to talk about the engineering aspect of developer productivity. So you have two speakers in price of one, free. Yeah, my name is Baruch Sadogursky. I'm at Baruch on whatever social media is trending this week. And I'm developer productivity advocate with Gradle. Developer, Java developer in particular in my past. And then I worked for JFrog for 11 years, and we pivoted with JFrog to DevOps, did a lot of DevOps stuff, and now back to helping developers being productive with developer productivity engineering. I co-authored a couple of books, DevOps Tools for Java developers and the Liquid Software. If you are interested, I think they're good, but you to be the judge of that. And my partner in crime today, Aleyner. And Eli is a co-founder of a company called Atomic Jar, which has something to do with test containers, I guess, judged by the t-shirt.
A little bit.
So yeah, Eli will get to that. He did a lot in the past, like really a lot in the past, and does a lot in the present as well. So you're in for a treat with Eli. The most important slide of this talk is this. If you go to speaking.jbaruch, and I'm shamelessly using a Switzerland top-level domain for that, you will find there a page dedicated for this meetup. It has the slides already there. The video, hopefully it is recording. Chances are it is recording. And all the links for everything that we are going to talk about today, including the books and everything else, it's there. In case you have a hard time remembering this pretty awesome URL, it's on the bottom of every slide, together with a bunch of other useful stuff. We have the, where it is here, we have the hashtag for Montreal JUG, we have the hashtag for developer productivity engineering, and we have our handles, both myself and Eli right here. On the bottom of every slide, very easy to remember. Okay. With all that aside, let's talk about motivation. And you can imagine that motivation and productivity go hand in hand, very related concepts. And what do we know about motivation? Well, we know carrot and stick. That, okay, who thinks that carrot and stick works? Any parents in the room? It does work, but it's limited. It's limited for certain scenarios, and generally it's not enough to provide motivation for intellectual work. And you know, as a developer, I love to think that my work is intellectual, as probably some of you. And for this kind of work, there are other things that motivate us. A great book about this topic called Drive by Daniel Pink, The Surprise Truth About What Motivates Us. I highly recommend you to read the entire thing, but in the end of the day, it boils down to three things: autonomy, mastery, and purpose. Okay, you don't have to read the book anymore. That's all. No, but jokes aside, do read the book. It's pretty awesome. But yeah, autonomy, mastery, and purpose. Now think about it. Think about your experience, especially as developers. Well, yes, money is important, and of course, money is important to the point that it's not an issue anymore. Like we kind of take it out of the table. If it's like way less than you actually need, then money will be the best motivator. But in some point of time, money is, okay, you get used to some level of income and you're comfortable with it, and then other things come into play. And other things are those. Autonomy. Can you do the work by yourself? Who enjoys, thank you, I didn't touch anything. Okay, who enjoys micromanagement? That's because you're the one doing it. Right? No one's who, like mastery. Mastery is who feels good about themselves when they do something professionally and they're good in their job. And then purpose, that's a little bit more trickier, but in the end of the day, we want what we do to make impact, to be purposeful, right? If you ever worked on a project that eventually didn't go anywhere and kind of was canceled or closed, you know the feeling that it is frustrating. Yes, I mean, if it was just carrot and stick, you probably shouldn't care because you got paid for the time that you spent, and who cares what's going on with what you did. But this is not how it works. You will really hurt knowing that what you did went down the drain and you didn't have purpose. So 3 of those. Now, there are aspects of our daily job, of our productivity, that is very closely related to all 3. For example, the flow, the state of flow as we as the developers experience when we write code, right? So things that annoy us when it's out of the flow, stuff like the build takes forever, I'm distracted to do other things, and context switch is terrible, right? You know, you run the build, it takes, 10 minutes. Should you stare at the log output or should you check your email? If you start checking your email, you'll probably be distracted by that. Coming back to the flow is extremely painful. You all know that. We asked other developers, yes, 84% agree that too much time spent waiting on build and test feedback either locally or during CI is actually very, very distracting. It's a pain. What else? Frustration like with flaky tests and generally the quality of tests. I have a flaky test. It's irrelevant most of the time. I don't even want to run it, but it does run as a part of the suite. It runs last, it breaks the build. And then I need to rerun the entire thing, and then it will pass, maybe on the 3rd time, and this is just annoying. And you can see inability to easily troubleshoot and determine the root cause of the build test and CI failures, including flaky tests. The majority of developers agree that it's terrible. And then stuff like, I have a feeling that everything is slower than it used to be. We experience it with our smartphones, and then we just upgrade to a new one. But if it happens with our build, we don't know why, right? It's just slower day to day. And again, the majority of developers, insufficient observability of analytics of build and test performance and regressions, failure trend and productivity bottlenecks. It is a real deal. Now, how it all ties back to motivation. In the end of the day, all those aspects of productivity are directly related to what we spoke about. Autonomy, tools and people aren't in my way. Mastery, tools and processes help me to excel. Purpose, I want to be productive, work on a product and be productive about it. This is productivity. And with that, let me introduce to you developer productivity engineering. This is something that we really hope can help all of us being more productive and thus give us better motivation. So what is developer productivity engineering? The most important tenet of developer productivity engineering is foster faster feedback. That's very clever. That's like foster faster feedback. If you okay, never mind. Yeah, both of us Gradle, test containers and atomic jar are in the business of fostering faster feedback. We're going to talk the entire evening about exactly that. Less context switching, less distractions, faster feedback. Eliminate toil. Again, something that we both in the business of. How do we do less stuff that annoys us without any purpose? Collaborate through effective tooling. We're working in a team. We need to pass information from one to each other. Is Slack effective tooling? Well, I guess depends what you compare it with.
Better than Microsoft Teams.
Is Microsoft Teams an effective tooling for collaboration? Maybe Miro? You know what? Maybe test containers. Maybe Gradle. Prioritize automation and eliminate bottlenecks. This is something that comes from a DevOps playbook, right? Eliminating bottlenecks, this is what DevOps is all about in continuous delivery of the product, which is a big deal. Obviously, we're all here to ship a product, but in the end of the day, what about our process of writing code? We can prioritize automation and eliminate bottlenecks there as well. Embrace rigorous observability for proactive improvement. This goes back to, hey, things are getting worse, I don't know why. Instead, I need to know what's going on and actually provide, be proactive in improvement. Outcomes over output. Geez, the outputs of logs and tests and what's going on. Can we even find what went wrong? That will be the outcome that we need to make sure that we know how to find through all the output. And dedicated organizational mindset. Does our organization pay enough attention to what's going on with developer productivity? They definitely pay attention to other things, like, for example, how fast, smooth we ship the product. This is why DevOps is such a big thing, because this is organization paying attention to the delivery process. But what about our developer productivity? Does the organization pay attention to that as well? So this is kind of the concept of developer productivity engineering. Now let's talk about what we can do practically in order to improve our productivity through DPE. Small DPE improvement make huge difference. I'll give you a couple of examples which hopefully are trivial. For example, generate code faster, better IDE. You go, you participate in the quiz, you win the licenses for IntelliJ IDEA, boom, your productivity goes up. You're not lucky enough, you use VS Code, well, you're okay. Still better than Notepad, right? That's what I say. But yeah, this is, I mean, the wins are obvious. Test better, test containers. Eli is going to talk about that and show you why it is so important. But the general idea is that you need to get better quality in your testing faster because you want faster feedback, right? Enforce better code. Sonar source, and generally like products from Sonar, are a great way to enforce clean code policies and improve your productivity through that. Test more reliably. We spoke about flaky tests. How do you detect those flaky tests? There are practices which don't require almost any tools, and I will just tell you the idea behind all of them is that if you have a failed test, you retry, and if it suddenly passed after it failed for the first time, you pay attention. I mean, retrying tests that fail, it's nothing new, right? This is what all of us do. If the test failed and you are not sure why, the first thing you do, you retry, which is great. But if it passes the second time, what do? You shrug and continue with your day. Like, well, that was weird, but okay, never mind. Flaky test detection is actually stopping there and saying, okay, I have a flaky test. It failed, but then it passed. I want to mark it. I want to do something without it. I want to make sure that it won't happen tomorrow. There are automated ways to do it. For example, the commercial offering from Gradle, I'm going to mention it a couple of more times because I need to make, to pay for the plane ticket. But there are ways that you don't need to pay anything for that. Faster, faster feedback, getting back to that, the most important stuff. Let's talk about feedback. So, feedback efficiency. What does it mean? IDE feedback. How long does it take? How efficient it is? It's immediate, right? You write something in your IDE, it marks it red if you made a typo or forgot a semicolon. This is sub-seconds. Build, seconds. You run the build, you wait for it to run, and then you see if it failed or succeeded. CI, minutes,
Sometimes hours.
sometimes hours, and then production, hours, sometimes it's days. We won't mention the other companies and products. What you see here is a reverse dependency on the distance from developers. The closer the tool to your hands, the faster feedback you expect, right? So here, this is your IDE sub-seconds, this is your build in seconds, this is your CI in hours, and this is your production in days. This is what you want to see. This is like expected. In reality, your build is not seconds. Am I right? Anyone actually has a build that runs in seconds with tests and everything? Not really. How about minutes, like less than 10 minutes? Okay, what, third? How about 10 to 20 minutes? Yep, and the rest either don't build or we won't pour salt on their wounds. Okay, sounds good. So the build is slow, and there is an excellent comics about it. So it is slow. That's like a given. I bet you saw this more than once. Now, you giggle, I hope, but that's not really how it works. When your build is slow, you don't enjoy this time. You're actually pretty miserable in this time because you need this feedback. You need this feedback to move forward and keep being productive, and you don't get it, so you don't really enjoy it. Instead, you are annoyed. Now, another problem with that is that, okay, how many of you think or know for sure that they understand everything that is going on in their build? Yeah, no, I mean like 10%. That's very cool. But 90% don't. People much smarter than I am, at least. Bruce Eckel. He's the author of one of the most important Java books that a lot of people learn their Java with, called Thinking in Java. Wrote a very angry piece about Gradle, how he passionately hates Gradle. It's fine, we're still friends. So the problem with Gradle is to do anything, you have to know everything, right? There is truth into it. And it's not only with Gradle, but it's profound with Gradle as well. You need to understand your build in order to be able to understand, for example, why it is slow. So not only it is slow, the developers have no idea why it is slow, because understanding the nuts and bolts of the build is usually not their job. Yes, we can hold them to a higher standard, and we can say, hey, you're not just a monkey programmer, you are a software developer, you are a software engineer, you are expected to understand those things. But in reality, developers have other things on their mind. They concentrate on their business logic and not necessarily on the infrastructure and build. So the build is slow, and developers have no idea why. What is build? Project setup, downloading the internet, all the dependencies, artifact generation, compilation, packaging, etc., testing, obviously, artifact deployment. Then the test obviously can be everything from I don't have tests, don't do that, to I have some unit tests, to I have unit tests and integration tests, and everything else that we need to verify the work that we did, right? So this can be very small, but also very large. Now, what can go wrong during the build? Well, project setup, downloading the internet, artifact generation, tests, and artifact deployment. When can it go wrong? Anytime. I hope not every time, but at any time for sure, right? Now, the build frustrates the developers for multiple reasons, for like things that go wrong. Now, how do we make our build faster? Where do we start? We ask ChatGPT. And ChatGPT tells us, if you have a Maven build, run it with skip tests. The first suggestion is just skip the tests.
It works.
What the actual fuck? Seriously. How does it help? It's a terrible advice. It's like do crack or whatever that was mentioned previously. Skipping the test defeats the entire purpose of the build. The reason why we run local build is not to create the artifacts. No one cares about the local artifact. Well, I hope. Anyone deploys artifacts to production from their machine? Don't raise your hand, please. You run local build for a single purpose. You want feedback. And then you do like, you know what, skip test. I don't need feedback. So don't run the build. You know what? Skip the compilation. Just SSH to production and write code in Notepad in production server because you don't need feedback apparently.
You can do that with PHP and...
True. And how does it work for them? Right? The question, how do we speed up the build, is not how do we give up on feedback. Is about how do we get faster feedback. This is faster feedback right there. Oh, I love it. Okay, so what feedback do we want? We want the quality gates that we already established as the quality threshold of our project. Where did we define those quality gates? We define them in our CI/CD pipeline. So it compiles, unit test run, integration test pass, coverage, code coverage, linting, static code analysis, dependency scanning, secret scanning, whatever static code analysis, non-functional requirements, like load testing and resource utilization and compliance. You do all that in your CI/CD pipeline. You do all that because this defines what quality checks your project should pass. Now, you are in your local environment and you run local build. You run it to get feedback about how well your code, your recent change, actually answers those requirements. Wouldn't it be nice to check all that in the, well, okay, I didn't expect this slide. But here it is. We do all those checks in your CI/CD. And this is obviously great because we managed to do them before we go to production. But it's actually not great because we want the same feedback in our local build. There are two types of feedback, asynchronous and synchronous. Asynchronous feedback is our CI/CD. We never wait for it, right? I hope you don't wait for it. But the results, when they come in, especially if something fails, are very distracting. You need now to stop doing what you are doing and go back and fix whatever didn't work. Synchronous feedback is your local build we'll wait for it, and we will be pissed off when it's slow. But in terms of, yeah, and the cut time between synchronous and asynchronous is your commit. Before your commit, this is your local build. You either see the feedback in your IDE, or you maybe run your build in your terminal, but this is where you wait for the results. Once you pushed it, well, it's pushed. You will get the result later, sometime, maybe. But you don't wait for it anymore. So, yeah, wouldn't it be nice to have all this quality of feedback in your build? You definitely want that. Because that's the idea. This is why you run local build. But it will probably take as long as your CI, and we spoke about it's way too long for wait for it. The idea of developer productivity engineering, our goal, Atomic Jar's goal, other companies' goal is provide you with delightful local build in which you get both. You get maximum feedback and it's as fast as possible. This is the goal. This is why we are here. So, what can we do? Generally, again, we can talk about, and maybe I will show you a couple of screenshots from the velocity and explain to it what is it, but generally, what do we want? We want skip what can be skipped, but no more. Skip tests is a bad idea. But, for example, if you know for sure, or very close for sure, that your change won't affect certain tests, you want to skip those particular tests, right? So, our modern build tools already do that. And this is called incremental build. So, don't build what didn't change. Don't build what isn't affected. It works, but it's not perfect. It relies on produced artifacts. How incremental build works? Well, let's see if we need to compile this thing. Well, we already have compiled artifacts in our build folder, and the sources didn't change. It means that we don't need to build when we run the build, and then the build is super fast. And it relies on architectural decisions. For example, what tests can be skipped is decided by our module composition of the project. We have our core module, we have our API module, we have our implementation module. If we change something in the implementation module, we don't need to run the tests of the API. If we change something in the API, we need to run all the tests because everything is related on the API, this kind of stuff. So, it means that both decisions of what to skip are not perfect. For example, if we run clean build, just like clean build or clean install or whatever with Maven, we deleted the produced artifacts. We didn't change any sources. We still don't want to compile, but your build tool won't know about it because there is nothing to compare to. So this breaks. The same with architectural decisions. Sometimes our modularity is not perfect. And sometimes the tests are failing in a completely unpredictable way. Maybe because we did something dirty with architecture. Maybe because our tests are not perfectly separated. Maybe there are some dependencies that are hidden. So both of those are not perfect. What should we do instead? We should use caching. Caching makes the build faster regardless of whether you have produced artifacts or not, because caching creates checksums of the inputs and then hashes the outputs against those inputs. So it doesn't matter what do you have in your build folder, if you didn't change something, it won't do the task that it should skip. Now, it also makes it build faster for everybody. Because not only you have local caches, you can also use remote caches. And remote caches can be distributed between the team or between the organization, whatever you decide. And this is particularly critical for your Monday morning build. And Monday morning build is a term that I invented, but you definitely should get behind it. You come from your weekend and you check out the code and you build it and it's terrible, right? Because, you know, things change over the weekend, people worked, maybe from home, maybe in other time zones, maybe, you know, that there are a lot of reasons why everything changed over the weekend. And your build will be slow. But if who knows about all the changes over the weekend? Your CI, because it constantly builds. If your CI shares the caches with you, your build will take what it takes to download the cache. That's all. And it's important for your productivity. And makes the build faster always, because even if you run clean builds, the caches will still work. Make all parts of the build faster, not only the stuff that is skipped by using incremental builds, like compiling and testing, but every task in your build can be cached. All we need to do is to make sure that the inputs, what this task takes in order to do its job, and the outputs, what this task changes, are clearly declared. So we can checksum the former and hash the later. If they are clearly marked and declared, it can be cached. It's true for building tasks and plugins. It's true for your own custom builds and plugins. Everything can be cached. Well, almost everything. Here's an example. Okay, I promised my boss that I'm going to spill some love on our product. Right, so the commercial offering of Gradle used to be called Gradle Enterprise. I hated this name because it's not only Gradle, it works for Maven and Bazel and SBT, and it's not only for enterprise. I mean, who doesn't want remote caching? Everybody. It's definitely not just for enterprise. I hated the name. And when I came, I'm like, okay, we need to change the name. And he's like, sure. And now there is a new name. It's called the Velocity. The problem is no one has any idea what does it mean. So I have to say, the Velocity, a product formerly known as Gradle Enterprise, it's not better. Well, for now at least. But anyway, so this is one of the things that Velocity does. It provides you the visibility that we spoke about. How do we know that things are faster or slower? So this is the performance screen, and you can see here the benefits of caching. In order to do the caching, you don't need to buy anything. Gradle has a built-in local cache and built-in remote cache. You just need to bring your own remote cache node. If you do want to buy the Velocity, it comes with it, but you don't have to. But in order to look at it, this is a very nice way to look at it without digging through logs. So what I want to show you, build time, 20 minutes, 12 minutes. That's accumulated over like a week or something. It's not like one build. Avoidance savings, 73%. Every time it ran a build, 3/4 of a build actually didn't run. Well, there is build cache overhead. What does it mean? This is the time that it takes to either download the cache or unpack the hashed results if we need them. But local build cache and remote build cache, those are the savings, and they are very, very significant. Again, this is something you can go to your project tomorrow and make it happen. 73%, 74%. Everybody will be happy, trust me. Now, another avoidance technique is answering the second question. How do we know which tests we can skip? Right? So skipping tests is a good idea as long as those tests are not affected by the code we write. And the question is, how do we know? What's their name? Meta, ex-Facebook, do a lot, except of the terrible stuff that they do, they also do some nice work. And this is the machine learning and artificial intelligence research that they do. One of the most important papers that they came up with within the last years is predictive text selection. Now, predictive text selection learns using machine learning what code changes affect what tests. Now, the thing with machine learning is that we have no idea why the results are the way they are, and we don't care, right? We throw in stuff to learn, and it comes out with some conclusions, which, even if they don't make sense, they are apparently true. For example, and this is bogus, it's not from there, it's just like something ridiculous that I can think of. If we make changes to the classes which end up with the name impl, stands for implementation, we understand why, right? And this is done towards the second part of the week, and people might be tired or something, then the certain tests will fail more than others. It has nothing to do with architectural decisions. It has something to do with something else. Or, in this particular team, when they do refactoring and rename methods, the tests fail less than the other team. Why? We can assume maybe they have IntelliJ IDEA licenses and the others don't. Well, it's actually true, right? Because IntelliJ will do smarter refactoring than other tools. Maybe. Or maybe not. But the thing is, we don't care. As long as we have a model that predicts testing failures in a way that we can trust with a high degree of confidence, we can start skipping tests that the model predicts that will pass anyway. Then we can skip tests with a high degree of confidence. And here's another example. This is from the velocity instance of the Spring framework. They run predictive test selection learning model in a simulation mode, which means they run all the tests, and then they compare it with the predictions of the model to check how accurate the model was. They waste a lot of time, but not enabling predictive text selection, but it's actually great for my presentations because I can show you how accurate the model. Because when the model already works, we don't know what to compare it with. So here are the simulations. 98.7% of failures, task and goal failures, are predicted correctly. Out of 2,700 tests, there are 37 that are guessed incorrect. This is over a week of the entire team working and building like crazy. 61 days, 44% of time that tests are running is saved, and there are 30% of avoidable tests. We can skip 30% of tests. Again, this has nothing to do with our decisions of which test to skip, which might be correct or incorrect. This is machine learning with very high degree of confidence. So skipping those 30% is almost guaranteed to be fine. Now, you can be very worried about 37 tests. Like, hey, Baruch, those are important tests. And we will skip them, although they would fail, and you didn't predict them. But remember, we're talking about local builds. We're trying to speed up our local build feedback. You know what time we care less about? CI. It's asynchronous. We don't care if it comes back with like 40% longer. It can run all the tests in the world and make sure that those are covered as well. Yes, once in a while, in 1.3% of the time, we will be really annoyed because our local test passed and then CI failed, because this is one of those. But this is 1% of the time. 98.7% of the time, we will be very happy that our build is that much faster. Once we skipped everything we can skip, we used caching and predictive selection, we need to speed up what cannot be skipped. Test parallelization is a great way to speed up. You use it on a local machine, but using the max power of local machine. And yes, this is a great reason to get on the latest hardware. Apple new event is announced on October 30th. It will be probably like new MacBooks. You want them? I got you covered. Look at that. This is the test that runs on this machine. This is M2 Max Pro Ultra whatever. Just running the normal Grail test. I have some test suite that takes 2 minutes. 1 minute, 59 seconds. I change one line of code, and it goes down to 10 seconds.
Skip test.
We decided we don't do that anymore. We're better than that. Instead, we do max parallel forks on all the available processors.
Okay.
Free, out of the box, 12 times improvement right there. Now you go to speaking.jbaruch. The presentation is right there. You take a screenshot of this slide, and November 1st, after Apple's presentation, you send it to your box. This is why I need the latest machine. Easy. Your boss is here? I'm sorry, but you cannot argue with numbers. You cannot argue with numbers. Now, let's say your boss is not as awesome as this lady here. And they are just being not very receptive to your charm and this nice presentation. You can still benefit from test parallelization, but in the cloud. There are a lot of CIs that already use that. It's called fan-out technique. Basically, your CI will fire up a lot of agents and run tests on all those agents. But you remember that we care less about CI and more about local builds? We can actually do it for local builds. You should enjoy the same. You can use the cloud to distribute test load, and you can use it, run all the tests that you need to run. Remember, don't skip tests. Instead, run the cloud, use the cloud to run the test. Now, this is a feature of the Velocity. It comes built into it, and you can enjoy it with Gradle, Maven, Bazel, or SBT. And then you can enjoy actually both of it, because the algorithm of your build will decide how much of your local power should be used, and then fan out the rest on the cloud. Yeah, so why you don't use CI fan out? Because you're relying on CI infrastructure for local builds. This is not what is intended to be. CI infrastructure is not optimized for real-time feedback. And you need real-time feedback. And then maybe the agents are not as fast. They are not set up with caching. They are not the fastest machines. Because you know what? You usually don't care. It's CI. It's asynchronous anyway. And we are talking about optimizing this, right? The last part of the 3 topics that we spoke about is don't let it slide. What I mean by that is the continuous improvement tenet of the DPE tenets that we spoke about. You start with something very, very low fruit. You measure local build times across time and environments and locations. And again, you don't need anything fancy for it. You can just take the build times that your build tool reports anywhere and just dump them into an Excel spreadsheet. It's terrible, it's toil, it's manual work, but you know what? It's better than nothing. If your boss is so awesome to buy you the velocity, you will get it out of the box, obviously. Did you notice how we already signed them up for the velocity? Right? So, but yeah, you know what? Just measure it. I don't care how. Just measure local build times and compare them. You will find interesting things. Maybe people started to work remotely because of COVID, didn't come back to the office, and their internet sucks. Did you know that they are not productive at all because they download the entire internet every day? Do they know how faster their build can be, even if only they start measuring it and comparing it with others? And then you detect down-facing trends, and you find root causes, and you improve. And this is, for example, how boiling the frog looks like. It starts like you don't even notice how it climbs from like what, 6 minutes to 8 minutes over like a month. You don't even notice that. But if you watch it, you will see the trend clearly. Right? So basically, trade-offs shouldn't be painful. And it's the same for tests. It's exactly the same trade-off. Expensive, slow, but prod-like. This is where Eli steps in.
All right, cool, awesome. Thanks, everyone. I'm Eli, but I'm in French-speaking Canada. I'm going to go by Eli. So,
also Hebrew-speaking Israel works.
There we go.
Eli,
there we go.
yes.
There we go. All right, cool, awesome. So, trade-offs and tests. We talked a lot about build. Let's talk about the tests, right? Baruch talked about how long the build takes and how long tests take. What are those tests actually testing? Are they actually testing the real thing? So when we talk about tests, there is usually the trade-off that Baruch just mentioned. You can do expensive, slow, but production-like environments, right? We all do it. Some staging environments and the like. Or you can do, naive, useless, but super fast. Which one do you pick? Anyone picks? No? No? We do all of them? All right, let's talk a little bit about how people usually approach testing, right? So how do you do the expensive but realistic staging environments? How many of you do staging environments? Staging environments? Deploying tests? Integration tests? Oh, there at least one. At least one. We got him. All right, awesome. Thank you. The challenge with staging environments is that you deploy those tests, but over time, the value of the test goes down. Why? Because of flakiness, as Baruch just mentioned, right? The tests that you deploy, you have data issues, you have deployment issues, you have all of the other things that can be happening in those staging environments. And the cost of maintaining those staging environments actually shoots up, because all of a sudden you have to start looking into why did those tests fail? Why did the more tests you deploy, the more things happen? So Baruch mentioned that I used to be on the AWS team. So the actual team I was on was S3 back in the day. And S3 had an interesting problem, right? We were developing what would become the storage for much of the internet. We were a team, fairly small team at the time, and we needed to get confidence in what in the software that we had, because we had to operate it and we had to be able to deploy that software to production at any point, day of night. The way we decided to get that confidence was to do staging environments, right? And deploy our software and run our integration tests. So the way we did it is we deployed those tests, and then we had to get the team to get excited and to know what's happening and address those issues if tests were failing. So we did. There was a good idea. We said we're going to put monitors all over our working environment, and on those monitors we're gonna show the status of those tests. And we're like, okay, we did that, and then tests were green, yellow, no one knows. We're like, okay, we need to get the team to get excited about those tests and to pay attention to those tests when they are failing. They're like, okay, we're gonna do it with a bunny. This is my bunny story. So we said, okay, great. We're gonna have integration tests all over monitors.
It's a bunny story.
All right, thank you. All right. Awesome, bunny story. So we had integration tests, and we had a bunny. And if 80% of the tests were passing, super happy bunny. With a carrot. Of course, happy-go-lucky bunny. You know, everything is awesome. If less than 80% of the tests were passing, the bunny would not be so happy. It was actually a little bloodied. And the idea was, you know, if tests are failing, we have to go and save the bunny, right? Less than 80% of the tests are failing. We have to go and save the bunny. We have to go and fix our integration tests. And as the project progressed, what I quickly realized is that the bunny starts getting more and more depressed over longer periods of time, because we had more tests, we had more issues that were happening, we had more reasons for the bunny to be very upset. So this is when I first realized that the idea of like staging environments and deploying code and having tests run in a staging environment actually degrades over time, and the amount of time we used to spend on fixing it actually went up. And when I talk to teams all over the world, I see that all the time. The solution to it is something I'm going to talk to you about today. And the idea is, you know, doing self-contained tests. So when you do tests, you can do mocking, right? Fast, but false, as we talked about, hard to maintain. You can do staging environments, which are somewhat realistic, right? But, you know, fragile and slow. Or you can YOLO, like Baruch was describing over here, and deploy it into production, right? It's awesome, it's real, but expensive and a little risky. I don't know how many of you work for banks. We can do PHP as well into production right away. So like what's the solution, right? Like you can do mocks, which are fast. You can do staging, which we just talked about. Or you can do test in production. I'm a little biased over here. So test containers is a framework that came out of the Java ecosystem that allows you to create self-contained tests. Tests that actually have real dependencies and that spin up dependencies that you need, and allows you to have tests that spin up an environment, run the test against it, and then you're done, blow it all away. How many of you have heard of test containers? All right.
Eli, your job here is done.
I'm done. Yeah, there we go. There we go. So what it allows you, so it's unit testing. The other way we talk about it is unit testing with real dependencies. It allows you to, you know, in your code to say, hey, I need a Redis instance. And with a few lines of code, you can say, hey, spin up a Redis instance, and it's going to be available for you to go and do it. I'm actually going to do a quick demo over here. And I'm going to switch my computers over here. Sorry. I'll go back to your.
I'll improve the experience while we show the demo.
There we go.
Faster computer switch.
Yes. Yeah, there we go. There we go. Let's see how this works. You want to try? There we go. All right. So this is an abstract test, right? The Spring, right? My first. And you can say, hey, this is an abstract test over here. I'm gonna need a Redis. I'm gonna need a Kafka, and I'm gonna need a Postgres instance for my test. And all the configuration that I'm gonna do over here is literally 7 lines, right? I'm gonna add some hosts. I'm gonna do the Bootstrap servers, and I'm gonna do the URL and username for my application. And then what I'll be able to do is I'll be able to go and write an app, right? This is a test class that inherits from abstract integration tests that actually goes and fires up my application and actually does some real integration tests. It's going to fire, it's going to look for requests, it's going to try and see what actually happens when the application runs. So I'm going to press the button, and show you what actually happens. So this test, Spring Boot application. See? Like that. There we go. The test is going to start. It's going to spin up Redis, spinning up Kafka over here in the background, and it's going to spin up Postgres. It's going to, as soon as it's done, what it's going to do, it's going to test the end-to-end functionality in a second.
Maybe.
Maybe. There we go. And when it's done, within 5 seconds, it gives me feedback. So what I'm able to do here, I'm able to go do a complete fast feedback cycle and get feedback on the changes that I'm making without waiting for a staging environment, without waiting for a CI server, without waiting for anything else. I'm able to do this even before I commit my code. I'm able to iterate and I'm able to go as fast as I can around that feedback cycle. This actually getting real feedback into the changes that I'm making. So I'm able to stand up my service, I'm able to get all of my dependencies that I need, and I'm able to iterate on this even before staging, before anything else. And I'm able to do it as I go through the various stages of my development lifecycle. Baruch, I'm gonna borrow your laptop back because I have a few more slides.
Are you ready?
There we go.
There we go.
Doing? As soon as
Here we
there
go.
we go. There we go. All right, cool. I'm gonna use this. And this technique is used by a few fairly interesting companies out there. Spotify just talked about their usage of test containers in every single service that they do. They just gave us $25,000 as an open source contribution. Netflix talked a lot at their conference, actually.
And we'll mention that, and you know where to find the videos and all. Yeah.
And this is available for anything that you can, like you can use test containers with anything that's available within a Docker container. And we have convenience methods for over 40 or 50 different technologies out there that spin this up. We have a beautiful modules catalog that gives you all of that information. And it's available in a variety of languages. So test containers.
PHP. No PHP. Well, they don't need it. They just go to production. Yeah.
PHP doesn't exist yet, but the C++ version was just released 2 weeks ago. There we go. Because the pattern of spinning up dependencies and getting feedback much earlier in the development lifecycle is applicable regardless of what language you do.
Generally, developer productivity engineering is not limited to any language.
There we go. I'm skipping to a few slides.
But it's not the same level of support according to the language, right? I
So-
mean,
sorry.
last time I checked the doc on test containers, I remember that with Java you could actually say that I want a Postgres SQL instance without providing the coordinates of the image.
Yeah,
Right? But for other languages, I remember that there was not such support.
it's coming. We are investing. This is coming. There's investment in all of those languages.
Okay, yeah.
Cool. We as a company, we employ many of the maintainers of the various frameworks that are getting better as we speak. All right. So as a company, right? So Baruch talked about his employer. I guess I am somewhat my own employer. So we have a couple of things that we do for people who adopt test containers. Test Containers Desktop, which is a free application for individual developers that actually helps you work with test containers. So it has features like the ability to debug your test containers powered dependencies. You're able to say, hey, by default, test container spins up dependencies, and when you're done, blows them all away. What if you want to debug? With Test Containers Desktop, you can say, hey, freeze my dependencies. Do not kill them. Or you're able, by default, test containers would spin up your dependencies on random port. You can map ports. You can say, hey, I need a specific port in order to be able to debug. And you're able to use some of our portals and so on and so forth. And then finally, for people who adopt test containers and use it in CI and want to use it in enterprise environments, we have Test Containers Cloud, which spins up your dependencies not only on your local machine, but we have a full cloud instance that those can be spun up on. This can be used in CI, this can be used locally, and so on and so forth. A nice architecture of how Test Containers Cloud actually works. All right, so.
Yeah, so just to sum up, the whole idea of developer productivity engineering is obviously not new. We try to put it in some framework and give you some structured way to look at it, but actually it's being done by a lot of companies already, and the gains are real. So in our survey, 84% of people who invest in developer productivity engineering actually claim that DPE dramatically improves productivity. And my favorite slide is this, because it has my favorite word. Developer productivity engineering foster developer joy. Same 84%, I guess the same people. I love the word joy here because this is what it's all about, right? Think about how you got started with computers. Think about your first Hello World, your first simple game, your first tiny app. You did it because it was joy. How about enterprise environment, web sphere development? A little bit less joy. DPE brings the joy back into software development, and this is absolutely awesome. And with that, you can learn more and try it today. So from our side, take the Gradle and Maven Speed Challenge. It's obviously if you go to speaking.jbaruch, you will find, or scan the QR code, it will take you to the same place. You will find like a small challenge that you can use on your build and see if it's faster. Maybe your boss doesn't want you to mess with your production build. She's still there. Yeah, maybe. We have a couple of ideas for projects, real-life projects like Spring Framework or others that you can try and play with them and see how fast you can make them. Generally, the whole idea of developer productivity engineering, as I mentioned, required an organizational mindset. We need champions in organizations. And thankfully, we have them in every single organization that tries. It might be you for your organization, and we provide the resources right here in order for you to become one and win prizes as you do that. We have tons of fun challenges that you get t-shirts and backpacks and swag and whatever for doing those challenges and being the champion. DPE handbook, Developer Productivity Engineering Handbook. It's also there for free for you to download and read. And the DP Summit that Eli just mentioned, it was a month ago. The videos should be there next week, I hope. Including obviously a lot of talks about test containers and a lot of talks about the velocity. Yay! And obviously, Eli, what people can start doing today with test containers?
Testcontainers.com, and you can get all documentation, desktop app, and everything else. And
start using it. And with that, I'm at Baruch.
Aleyner.
Aleyner. This is Montreal JUG. DP is the topic. And speaking.jbaruch is where everything lives. Thank you very much.
I got a question. It's for you, Eli, and I'm actually going to be the advocate of the devil. Just so you know, I love test containers. But in my previous job, people decided to go and embrace AWS SAM. And since you're familiar with AWS, I mean, since S3.
A little bit.
With AWS SAM, you've got AWS SAM test. And the way it works is that it's not using test container to actually simulate the environment, but it's going to basically do its own, let me remember. I think it's going to actually use real AWS resources to...
it uses real AWS. Okay, cool.
As far as I remember. So, what is your take on that when we deploy to the cloud? Do you think the cloud providers are best suited to provide my test dependencies, such as databases and whatnot, or do you think that test container is still relevant in those environments, even if at the end of the day, I mean, of course, you're close to production using a PostgreSQL container, but if you're using the AWS own implementation of PostgreSQL, maybe you're even closer to production.
So, thank you for the question. There we go. The question was about using AWS specifically and about using AWS implementations for their services. And I think the answer to that...
And the fact that they provide it for free in the infrastructure, so it looks like some of the compromise that we mentioned is not there, right?
So it's not either or. So when I look at test containers and I look at what are the most popular...
Don't shut down.
Oh, sorry. Okay. Sorry, I thought you were talking to me. All right, cool. All right. So one of the most popular modules for test containers is local stack. So people actually spin up local instances of AWS services to test against them, right? And people get confidence through that, and they're able to do it much, much faster than waiting for however long it takes for AWS services to do it. Other people, they need to use core native AWS services, and of course, AWS and Azure and GCP are very interested in using their core native services for actual testing because it spins dials. But I've seen lots of people use test containers with local stack and equivalents, and there is a module for Azure and there is a module for GCP. And I've seen people use test containers for functionality testing and then start using the actual implementations for the cloud. So it's not necessarily either or. I've seen people do both types of feedback.
And we can also assume that the tests that are run against the native infrastructure take longer. And that means that going back to our synchronous, asynchronous distinguishing, we can run test containers in our local build to get faster feedback, which is close enough, and then do the real thing in the CI, which will give us the confidence that we need without being in the way for our local development.
Good.
It's not the same, but almost the same. For instance, when you test locally, you cannot really test IAM permission. So does IAM permission need to be tested further in CI, or do you have any plans to, I don't know, like a magic implementation with a specific container to say, hey, I need Lambda invoke IAM permission? So, because of course, when you even have like local container to test S3 or DynamoDB, this is great to test if the request is correct, if the schema is good, but at the end, if you deploy it and you don't have the DynamoDB put item permission, this is broken.
So I mean, fundamentally, you get the trade-off here is a trade-off of getting faster feedback or doing, or with cloud services in particular, is using the real thing. Eventually, we will go there. We will go into cloud testing and actual. For now, we don't have anything to say. So. Okay. Specifically, so you can use things like local stack and stuff like that, which are great partners of ours and native implementations.
Okay.
I'll say as much.
We wait for reinvent.
Go
ahead.
So you may interrupt if you want to ask yours. Gradle, there used to be a Maven cache provided by Gradle.
Yeah,
that's still the thing.
Right. So there are a couple of things regarding Maven support. Right. So generally, the Velocity have almost on par support with Gradle, which include local and remote cache, which include test distribution, predictive text selection, and everything else. Now, one of the benefits of using the Velocity with Maven was that it added the local caching that Maven lacked, and that's the local Maven cache provided by Gradle. Now, Maven 4 has experimental local cache support that does the same thing. Do you want to start using Maven 4 right now and use whatever experimental features in Maven, I don't know, but you can definitely start looking at it, and very well might be that you can at least get the local caching in Maven without needing to purchase, to have a license of the velocity in hand. Yep.
Yeah, I saw that. The concept of reproducible builds is getting in the head of Maven.
Oh, yeah.
Now when you do something, it might do the same thing twice.
I mean, we probably should be upset because that was a nice upsell for Maven users, but we're actually very happy because we want the developers to be productive as much as possible. So yeah, it's great.
Yeah, they're kind of catching up because even Maven Daemon is really like great.
And Maven Wrapper is like great. Yeah, and that's great. I mean, in the end of the day, if we still have a lot to offer, even if all the open source features will be on par. We're not worried, so we're really happy that they're catching up. I mean, I don't know about, probably the developers of the build tool should be worried. I'm, as a developer productivity advocate, I'm actually very happy.
So since we're talking about obviously caching and build tools, there are two trends. I mean, two recent trends during for the last decade. One is that people are switching to microservices for good or for bad. But now, when, for example, you say that your build can last tens of minutes or even hours, I mean, with microservices, usually it lasts just 30 seconds or 1 minute.
Yeah.
And also,
if your microservices are isolated enough.
If you are isolated enough, exactly. And
yeah.
then you can use test container to simulate the interactions with other microservices as well.
Exactly.
Yeah, definitely, we can do that. So it kind of lowers the
importance.
No, I'm just saying it kind of lowers the interest of having something fast and cached. And then the other trend that also goes with this movement is more and more people are using things like GitHub Actions that actually allows you to do caching as well. You can do caching with, and they usually cache with S3 or whatever cloud provider they're using. So at the end of the day, where do you see the velocity fit into this reality where today most people, they have very fast builds, and they also tend to cache most of their things in GitHub Actions, for example.
Right. So first of all, the GitHub Actions is very, very easy to answer. GitHub Actions is a CI server. It's an asynchronous feedback. It's nice when it's fast, but you don't wait for it anyway. It's a little bit irrelevant to our discussion of local build.
Yeah, that's true.
Right? I mean, I'm all for making your CI build faster as well. It's going to be nice, but it's not as critical as your local build. Now, for the local build and for microservices, first of all, there is a little bit of reckoning with all the microservices thing. In the end of the day, microservices is not a silver bullet. It's a trade-off. And what you save in stuff like encapsulation of modules, you pay in the sophistication of infrastructure between the microservices. So it's not that it's a silver bullet and now we're all doing microservices and all the problems in computer science solved. And we see the trend that people now prefer sometimes not even do that. Now there is another problem that microservices, as everything else in our industry, suffers from cargo cult syndrome. Right, okay, so Netflix does microservices or Amazon does microservices, they came with microservices, now we do everything with microservices. What does it mean? Well, we don't know, probably we should have some parts of our project living in different projects and IntelliJ and build by themselves. You sure that's what it means? But I don't know, it's micro and the services, sounds good to me. But obviously it's not, and then the problem is that when we think that we go with a thing and we actually don't, it does the opposite of the benefits. What I'm trying to imply here is that if you are not doing your microservice right, for example, you don't have boundaries of dependencies between them and they dependent on implementation of each other, you think that you don't need to test the rest of the microservices and your build is fast. but you're actually gonna break them without even knowing, and you will discover it in production, which apparently is not very good time to discover that you broke something. According to Ellie, I think it's fine. So yeah, predictive test selection can help with that, because they don't care, the machine doesn't care if you think that you are doing microservices or not. All it cares about is you wrote some code here, it broke some tests here. You think it's another service? I don't care, it's still broken, right? So still, when we do those tests that include tests between services that we need to do unless to make sure that our services are independent, those should be avoided and sped up as much as possible as well.
Test container not.
You've grilled him, now you grilled me.
Yeah,
Good.
no, it's fine. It's fine. One and one.
Perfect. I had
Good.
annoying questions. A nice one. Under test containers, you use the Docker Java API, so there's a library. Who develops that?
I don't know.
Is it like a Baruch or?
Ryuk is a container that we develop, but the Docker Java API, I don't know who develops it.
It's not from me.
Huh?
Because as soon as it goes crazy in test containers, you just go there normally and then you fix stuff when it's not supported. And it's magnificently well working, but they don't know what Javadoc is at all.
Java?
Javadoc.
Okay.
So they don't document. There's no document. I don't know how you cope with that actually. For me, it's a mystery.
You don't know how
look
to.
at it, it's like, what the heck? How am I supposed to do that? Like,
Sorry.
No single line of anything.
For test containers in Java or for Docker?
Is perfect.
Okay.
The Java API under so the Docker Java API is a mystery of usability. I don't even know.
I think Docker actually wrote it.
I don't know. That's why I'm not going to answer. So I'm not going to put anyone under the bus. I don't know. I'm happy to go and find out.
Yeah, I'm curious. It's like it's actually super useful. It's just you have no clue what it's doing. Then what were my two other things?
I need some grilling. Like this is.
That was like, I don't know. Next question.
We wanted to integrate test containers when we were trying to run Kafka on Windows. I don't want to remember that, but anyways, I remember we had a problem with running it with Podman, I believe.
Give me 1 second. Folks, before we get into like really troubleshooting test containers in some weird environments, I wanted to make sure that you are all obviously can leave whenever you like. Before that, there is a couple of mandatory things. We need to take a selfie, right? So, Eli, where is your phone? My phone is recording, I cannot use it.
We need to run the quiz as well.
And we need to run the quiz?
Nobody leaves before the quiz.
Yeah, so let's do all those things so people will feel free to leave if they are not interested in this.
After the quiz.
Yes. They are not interested in this particular like tiny question or anything. Okay, you good? Wisdom here, wisdom everybody.
Oh, okay. Wait.
It's like his first meetup or something.
The other way around.
Okay, here you go. People, we just gather here. Okay, here we go. That's better.
All right.
Okay, no, but you need to count and let people
1,
wave.
2, 3, wave.
All right, thank you very much.
Thank you.
And now let's do the quiz, and then everybody can grill Ellie
Ellie
and
on test containers.
other people can
So
leave if they want.
you were saying Kafka.